Previously, we discussed some examples for moment of inertia, and today we'll continue on with number 2. So again, number 2, determine the moment of inertia of the cross-sectional area of the member shown in the figure about the x and y centroidal axis. So we're looking for two things, Ix and Iy. So we have sort of an irregular shape. So we need to divide this into simpler shapes in order to get the total moment of inertia. So let's start with dividing this into sections. So first, obviously, these should be divided into rectangles. So the way that I'll divide this is like this. So one rectangle, right? And then another two for the sides. And then let's label our rectangles. And then okay. So let's call this block A, block B, and then plus block C respectively. So this is our centroidal axis, right? So you gotta take a moment about that point. If you've noticed, the centroidal axis is directly at or acting on the centroid of block B. So it's easier to take the moment of inertia for that because we don't need to do parallel axis theorem. So let's start with block B and then solve for the x and y moment of inertia respectively. So let's start with Ix. Can anybody give me the equation for the moment of inertia of a rectangle? Correct, Colin. No, nope, it's not 1/3 h cubed. Anyone else? That's for the base, bh cubed over 3. Correct, Rafaela. Bh cubed over 12. So base is this total length, which is 600. Height is this given 100 over 12. Please solve. What's the answer? You can write in scientific notation. Correct, Colin? Correct. Chua. J-Lo. With 5 times 10 raised to 9. Okay, and then let's do the same for Iy. Now, what's the equation for Iy? Correct, Simon? Who else? Okay, correct, Terry. HB cube over 12, so it's just the opposite of this. So again, height now is 100, base is still 600. Please solve. What's the answer? Fred J. Lau, and Gab. Francisco Chua Legado. It's 1.8 times 10 raised to 9. Okay, we're done with block B or rectangle B. Now we'll move on to rectangles A and C. Now, before we do that, let's consider the positioning of A and C. If you've noticed, A and C are equidistant from your y-axis. Okay? Meaning, also they're at the same orientation. Meaning they'll give the same moment of inertia about the y-axis. Same thing, they're also equidistant from the x-axis. Okay? So also that means they're gonna have the same moment of inertia about the x-axis. They're basically at opposite ends of each axis. So meaning I can just solve this as a whole. So for both A and C, Ix, Iy are the same. Let's start with Ix. Now for block A and C, their centroids aren't at their centroidal axis, meaning I need to do parallel axis theorem. So the centroid of each block would be here. Okay, this is the centroid for A, and then centroid for for C. So the equation for parallel axis theorem is I bar plus AD squared. In this case, that's y squared. Moment of inertia about the x-axis considers distances y. So we already know centroidal moment of inertia for rectangle, that's bh cubed over 12 plus AD squared. So let's write out your equations immediately. So base, and let's focus on rectangle A. Base is this, which is 100. Height is this. So total height of this is 400. Height of your block B is 100. Therefore, for block A, it's merely 300. So 300 cubed over 12. And then plus area. So area of a rectangle is base times height. Again, base is 100. Height is 300. And then we need to compute for distance from the x-axis. So let's see. So this is your centroid. You want to get distance from this point. So to get that, again, considering total length of 400, this is what we need. Yeah, this length. So 400, I'm going to subtract this, which is half the height of your block B. And total height is 100, half of that is 50. So 400 minus 50, and then minus this, which is, again, half the height of block A. Block A is 300, so half of that is 150. So 400 minus 50 minus 150, that's 200. Okay, that's why distance of centroid of A from x-axis is 200 squared. Please solve. What's the answer? Correct, Marilyn and Rafael Asagi. Leosis Asagi. So let's just write 1.425 times 10 raised to 9. Okay, let's move on to IY. So IY is the same. Once again, centroid is not along the centroidal x or y axis. So that means IY using parallel axis theorem is IY bar plus AX squared. You already know IY bar, that's HB cubed over 12. So that's 300 times 100 cubed over 12. area is still 100 times 300. Now the distance is different. So this is what we need. So to get that, consider that from this edge to the centroid of your axis, or at the intersection of your axis, that's half the length of your block P, right? So this is 600, so half of that is 300. However, the distance is only at centroid of A. So I need to subtract that by this length, which is half the base or half the width of block A. Total width of block A is 100, therefore this is 50. So 300 minus 50, that's 250. Okay, so 250 squared. Please solve. What's the answer? Correct, J. Lau. Correct, Simon. And Rafael. Pasagi. 1.9. Now, to get the total moment of inertia about the x-axis and the y-axis, you just get the algebraic sum. So total Ix is summation of your Ix. So we have first this 5 times 10 raised to 9. So 5 times 10 raised to 9 plus 1.425 times 10 raised to 9. However, this is the moment of inertia of your two blocks. So you can just multiply this by 2. Please solve. What's the final answer? Correct, J. Lau, Rafaela. Will compute. Oh, sorry, this is 7. 600 times 100. Correction, this is 7. 7. Correct, Rafael. It's 2.9 times 10 raised to 9. And then unit is just millimeter raised to 4 for moment of inertia. Now let's do the same for Iy. Again, that's just a summation of moment of inertia y. So 1.8 times 10 raised to 9 plus twice 1.9. Please solve. What's the answer? Correct. Correct, Simon. Francisco. Legado. 2 points. Correct, Simon. And Legado. It's 5.6 times 10 raised to 9. And once again, our unit is just raised to 4. And there, that's how you get the moment of inertia. Any questions for number 2? Please answer in the chat. Okay, great. No questions. Let's move on to number 3. Determine the moment of inertia of the T section shown in the figure with respect to its centroidal axis. So moment of inertia about the centroidal axis. So first, I need to find the centroid because I don't know the centroidal axis. And remember, to get the centroid, almost the same steps as moment of inertia, you divide your shape into simpler shapes. So let's do that. We'll divide it this way. As you can see, we immediately have 2 rectangles. Mhm. Yeah. So this is block 2, and then this is 1. So that's A1, A2. So remembering how to get centroid, you start with A1. That's just a rectangle, so base times height, 2 inches, times height, 8 inches, that's 16. And then area 2, base times height again, base is 8, height is 2, again 16. Total area is 32. Okay, so now that we have that, what we're concerned with is y bar, because this shape is symmetrical along the y-axis. So I already know your centroid will be somewhere along this line. I just need to know at what height from the base. That's why we're just looking for rather y bar. So to solve, we have a y bar equals summation of ay. A y bar. Let's start with a1. Okay, we want to get, this is the centroid of your a1. We want to get this. Let me just move everything. So this is your y1. Okay. Can anybody give me the y1? Correct? Rafaela and Marilyn. Leosis pangalan. Huwag niyong kopyahin yung sagot sa nakikita niyong solutions. Iba yung ginawa kong label for each rectangle. So it's not 1. This is 1. Okay. So again, please try to solve and not just copy the answer that you see in whatever you're looking at. So very good, correct. It's 6. Why? So first you have 2 inches. And then we need this, which is half the height of your rectangle 1. Rectangle 1 has a height of 8. And that is 4. So 4 plus 2. That's 6. Plus, and now this is your rectangle 2 with centroid here. So A2. So this is the centroid of that. Right? And that's half the height of your rectangle 2. Height of your rectangle 2 is 2. Half of that is 1. So this is 1. From this, please solve what's y bar. Y bar. So you divide it by 8. Correct, Nicolas, Marilyn, and Naomi. And you also, Buena. .5. Okay. And that's not what we're looking for as our final answer. We're looking for moment of inertia. So specifically about X sub O axis. And X sub O is here. So moment of inertia about this line. So IXO. So our shapes and the centroids of those shapes don't fall on your centroidal axis. Meaning, again, we're going to use parallel axis theorem. So that would be summation, since there's two shapes, summation of I x bar plus AD squared. AY squared. Okay. Now, in the previous example, right, we did the moment of inertia first of each part, and then we took the sum. You can also just write all of that in one equation as well, instead of separating that. So writing in a single equation, let's start again with block 1. So that's IX bar plus AY squared of block 1. So this signifies all values for block 1, and then plus IX bar plus AY squared of block 2. Now let's just write our values. So these are all just rectangles. So IX bar is, we already know, BH cube over 12. So base of block 1 is 2. So 2 times height is 8 cube over 12 plus area. Area of this is base times height, so 2 times 8. We want to know distance of the centroid of your rectangle to the centroidal axis. So now this is what we want to know. Okay, let's call this y2. To get that, look at our labels. We already know this. That's your y1. And y1 is 6. What I need is just this height. So all I have to do is subtract y bar. Okay? So y1 minus y bar. Y1 is 6 minus 3.5. And then squared. Now let's move on to block 2. Block 2, base is 8, height is 2. So BH cube over 12 plus AD squared. So base times height, 8 times height, 2. And now, this is what we want to get. Okay? And then let's call this y sub 2. Once again, to get that, just look at your measurements. I already know this total height, which is y bar. So I just need to subtract this, which is the distance from the base to the centroid of your rectangle 2 or shape 2. Half of the height is 1, so that's y bar minus 1. So y bar again is 3.5 minus 1 squared. Now all you have to do is solve. Please solve. What's the answer? Correct. Correct, Nicolas and Rafael. Buena job. It's 290.67. And then unit, inches. So inch raised to 4. And that's number 3. Any questions for number 3? Please answer in the chat. Thank you, Zaira. It's 2.67. Okay, no questions. So let's move on to the final problem solving number for this course, number 4. Find the moment of inertia of the indicated x-axis for about the indicated x-axis for the shaded area shown in the figure. So now we don't have just rectangles. We have a semicircle. So let's solve. So moment of inertia about the x-axis. Your x-axis is at the base. We have more than one shape. We don't just have a simple rectangle. That means to get moment of inertia, you're going to get the algebraic sum of the moment of inertia of each shape. The first step, identify your shapes. Once again, I said rectangle. So let's start with the rectangle. Ix. Again, x is at the base of your rectangle. Can anybody give me the equation for moment of inertia of a rectangle about the base? Correct. Colin, Paulo. Paulo. Correct, Rafaela. Buena. 2.7. What else? Illustrate. Correct, Joaquin. It's h cubed over 3. Right? About the center, h cubed over 12. About the base, h cubed over 3. Base of your rectangle is this. To get that, look at your given measurements. We're given this, which is the radius of your semicircle. Radius would also be equal to this length, right? That's also 4. Same as this also 4. So in short, the diameter of your semicircle is the same as the base of your rectangle, radius r times 2, so that's 8. So 8, height is given 10. Please solve. What's the answer? Correct. Paolo and Naomi. 12. Hermoso. So 2666.67. It's not a whole number. Please store that. Now, as mentioned earlier, the next shape would be a semicircle. So semicircle. Okay. So unlike your rectangle where we already know moment of inertia about the base, since your x-axis is at the base, we don't have a direct equation for semicircle. And remember, whenever we have something like that, what we'll do is use parallel axis theorem. So Ix is Ix bar plus AD squared. In this case, that's distance y, so y squared. Does anyone remember what's the equation for the moment of inertia about the central axis of a semicircle? Very good. Rafaela Francisco. Malangan. Legat. So for those who forgot, let's recall. Semicircle. We're looking for a moment of inertia about centroidal x-axis, so that's Ix bar. This is your Ix bar, so that's 0.11 r raised to 4. Okay? So here at the top, that's just Ix, x being the base or the diameter of your semicircle, and Iy bar. So we're looking for Ix bar. So once again, 0.11 r raised to 4. Area of a semicircle is just 1/2 r squared. And then we're looking for this y. So to get that y, let's have this. The centroid of the semicircle is somewhere here, okay? And I want to get that distance to the x-axis. So we don't have an equation for this point to this point, right? What we know is from the centroid to the straight edge. So from centroids, you should be familiar with it by now. Distance of centroid of a semicircle or even a quarter circle to the edge is 4r over 3 pi. So 4r over 3 pi. Therefore, to get this length, that's just 10 total height minus 4r over 3 pi. So 10 minus 4r over 3 pi. Now let's just sub in our values. So 0.11, radius is 4 raised to 4 plus 1/2 pi r squared 10 minus 4 times 4 over 3 pi. Please solve. What's the answer? Correct, Pamela? Paolo? Mine. Squared, squared, squared. Correct, Joaquin. Anyone else? Wala pang 2 points. Okay. Correct, 1760.53. Again, this ain't a whole number. Store it, calculate. Now, let's get the final answer. Ix is the summation of your Ix. However, semicircle is an empty space. Therefore, what we'll do, okay, let's take the moment of inertia of the shaded area. So let's call moment of inertia of the rectangle Ixr, and then for semicircle Ixs. Okay, so that's equal to Ixr minus the empty space, which is Ixs. Please solve. What's the final answer? Correct, Zaira and Alyssa Tamayo Ortiz. It's 906.14. And then unit inch raised to 4. Okay, so that's number 4. Any questions for number 4? Please answer in the chat. No questions? Okay, so that ends all of our topics for statics of rigid bodies. Any questions, clarifications? about everything so far? No concerns? Okay.
Ma'am, ako po may tanong po ako, ma'am.
Yes?
Ma'am, dun po kasi sa module 1 ko, ma'am, bakit po kaya IP pa rin po yung grade ko, ma'am? Nag-take na po ako ng IP remedial, ma'am, yun sa exam po. So,
Wait, let me check. Sorry, what's your name?
Ma'am Renzo Esteban po.
Okay, so let me just check. Module 1, right?
Opo.
Okay. If you look at the column MG1 for IP students, it's not yet 60 or it's not yet 70%. You need a 70% or higher under the grade column MG1 for IP students.
Ma'am, nag-take na po ako, ma'am, eh.
You can retake the IP exam as many times as you want. I can see that it's not yet perfect. You can try to make it a perfect score para maabot mo yung 70%.
Ay, okay. Sige po, ma'am. Salamat po.
Okay. Any other concerns? Okay, wait lang. Quiz 3. For those who submitted your answers at directly 1:30, all of your attempts will be graded as needs grading. So that just means I need to grade it manually. So yeah, I will be accessing it manually later so that you'll see your grade. I haven't done that yet. Any other concerns? Yes. Modular exam for module 3 is this Saturday. Same time, 12 to 1:30. Zoom meeting, same as before. And then same deadline for solution, it's that Saturday. It's at 11:59 p.m. on that day. Also, you have one remaining Coursera activity. So that's week 5. Please make sure you send me the correct screenshot, okay? When I check at Saturday, you won't have any chances anymore to resubmit the correct screenshot if you gave me the wrong one. So make sure the screenshot that you're showing me has your name, title of the activity, the week of the activity, and your score. So if you want as reference, what your screenshot should look like is in the orientation PDF file uploaded under lectures in your Blackboard. This Thursday, you'll have a group activity, hopefully. So final group activity to give you additional points to increase your grade for Module 3. Later, I'll create a submission link later for the Coursera. Okay, so this Thursday, as of now, group activity, please join. We're gonna have groupings on Thursday as well. Okay? If you want, you can try grouping yourselves already. I think you're 40. So, don't want a lot of groups. So 6 members per group. You can group now, but I'll still group you on Saturday as well. Just keep in mind it's 6 members per group. And then again, submission link. I'll make one later. Okay, wait, let me check for the IP grade. Module 2. Okay. Oh yeah. Okay. I see. And updated. You can check your grade again. I've updated it to 3 for your M2 grade. Well, yeah, for those who don't have group, I'll group you on Thursday as well. But those who can, you can group yourselves already to save us time. Okay. Anilon. Let me check. MG2. Okay. Again, updated. You're welcome, you're welcome. Any other concerns, clarifications, problems? Since we have a lot of time left. Okay, wala na. So again, deadline for Coursera week 5, I think is this Saturday, 11:59. But you can send it earlier so that you can see your final grade earlier as well. So that if you have any concerns, you have time to message me. So final quiz on Saturday again. Coverage is everything I've discussed in week 3, module 3. Open a Zoom meeting, join the Zoom meeting, no video, no score as usual, same as what we've been doing. All right, so we have one final activity. Your final journal activity, final assessment. So same as usual, I'll upload the activity or submission link for this under week 11. So again, I'll do that later. So number 1, what have you learned in this class? Number 2, what do you think about your overall performance? So number 1, what have you learned? Since we're done with all the lectures, we're about to answer your final exam. Just write whatever topic stuck with you the most now that you have your module 3 topics. What you've understood and what you've understood the least. Okay, just write it there. And then number 2, what do you think about your overall performance? So you just have one remaining quiz left. So you should have an idea on how you performed overall in this course. So again, do you think you're satisfied? Are you able to increase your grade based on your module 1 and 2 grades and things like that? 3 suggestions for like the next set of students to take this class. Do you have any more suggestions that we can do to make this course better? And then 4, if you have anything else to say, write it under final words. Okay? Again, I'll upload all the submission links later, so you can just check it out if you want to submit already, since you have a lot of time today, or rather in this class. Okay, so since you don't have any more questions, see you on Thursday. You may go. Bye, class.
Thank you, ma'am.